There is a question that has never fully left the minds of those who look up at the night sky long enough to really think about what they are seeing. It is not a complicated question, at least not on the surface. In fact, when you first hear it, it might even seem a little too simple, a little too obvious, the kind of question a child might ask before falling asleep. And yet, this question has quietly haunted some of the greatest scientific minds of the last 100 years, and it has never, not once, received a satisfying answer. The question is this: where is everybody? That is it. 3 words if you leave out the punctuation. Where is everybody? Not a dramatic question, not a question that seems to carry the weight of the cosmos inside it. And yet, when you sit with it for a moment, when you really let it unfold in your mind the way a piece of paper slowly opens when you drop it into water, you begin to realize that this question might be one of the deepest, most unsettling, most quietly beautiful puzzles the human mind has ever stumbled into. Tonight, we are going to sit with that question together. We are going to let it breathe. We are going to follow it slowly, carefully, the way you might follow a path through a forest at dusk, when the light is low and every shadow could be something, and the air carries that particular kind of silence that makes you feel both very small and very alive at the same time. And if, at some point along the way, you drift off to sleep, that is perfectly fine. The universe will still be here when you wake up. It always is. Before we go any further, if this kind of slow, thoughtful journey through the mysteries of space and time is something you enjoy, consider leaving a like on this video and subscribing to the channel. It takes just a moment, and it helps more people find their way to this quiet corner of the internet where we explore the biggest questions there are at the pace they deserve. Now, let us begin. Imagine, for a moment, that you are standing outside on a clear night, not in a city, not somewhere with streetlights washing out the darkness, but somewhere truly dark, a field maybe, or the top of a low hill somewhere far from the noise and the glow of human things. The sky above you is not black, not exactly. It is deep. It has depth to it, the way the ocean has depth, and when you look long enough you begin to see that what seemed like a flat ceiling of scattered lights is actually something more like a window, or maybe a door, into something that goes on and on and on without any end that you could ever reach or even imagine. You are looking at roughly 5,000 stars with your naked eye, on a night like that. 5,000 points of light, each one a sun, most of them far older than our own. And that is just what you can see without any tools, without any technology, just your 2 eyes and the darkness. The actual number of stars in our galaxy, the Milky Way, is somewhere between 200 billion and 400 billion. Numbers that large do not really land in the human brain the way smaller numbers do. They sort of float there, acknowledged but not truly felt. So let us try a different approach. Let us try to feel it instead of just knowing it. Imagine you had a jar of sand, a big jar, the kind you might see at a beach shop somewhere, filled to the top with fine white sand. That jar might hold around 1 million grains of sand. 1 million. Now imagine filling not one jar, but 200,000 of those jars, all the way to the top. All that sand, all those individual grains, every single one of them representing a star, a sun, something that burns with unimaginable heat and energy across unimaginable distances. That is just our galaxy, just one galaxy. And there are, as best as we can estimate right now, something in the range of 2 trillion galaxies in the observable universe. 2 trillion. Your brain has already let that number go, and that is okay. It is what brains do with numbers like that. They acknowledge them and then quietly set them aside, because there is no drawer in the human mind large enough to hold something like 2 trillion galaxies, each containing hundreds of billions of stars, most of which we now know have planets orbiting around them. Planets that are just sitting there, circling their suns in the dark, some of them ancient beyond anything we have words for. And here is where the question comes back. Here is where those 3 quiet words return. Where is everybody? Because if the universe is that large and that old and filled with that many stars and planets, and if even a tiny fraction of those planets have the right conditions for life, and if even a tiny fraction of those living worlds eventually produce intelligent creatures who look up at their own night skies and wonder, creatures who develop language and tools and eventually technology that can reach across space, then the universe should be loud with signals. It should be full of evidence. We should have heard something by now. We should have seen something. We should not, by any reasonable calculation, be sitting here in the dark, in silence, wondering if we are alone. And yet, here we are. This tension, this enormous, quiet, almost unbearable gap between what the math says should be there and what we actually observe, which is nothing, is what the physicist Enrico Fermi captured in a single lunchtime remark back in 1950. He was eating with colleagues at Los Alamos. The conversation turned to the possibility of extraterrestrial intelligence, and Fermi, in the middle of what was apparently an otherwise ordinary lunch, looked up and said, essentially, "But where are they?" The remark became famous not because it was complicated, but because it was so simple and so sharp. It cut straight to the heart of something that no one had quite named before. And ever since that afternoon in 1950, scientists, philosophers, writers, and ordinary people who happen to look up at the sky too long have been trying to answer it. We call it the Fermi Paradox. The word paradox is important here. A paradox is not just a mystery. A mystery is something we do not yet know. A paradox is something that should not be able to exist. A situation where 2 things are both true, and yet they seem to contradict each other completely. The Fermi Paradox at its core says this: the universe should be full of civilizations, and yet we see and hear nothing. Both of those things appear to be true, and they cannot both be true at the same time, and yet they are, or at least they seem to be. Tonight, we are going to walk through the landscape of this paradox slowly and gently. We are going to look at what ancient civilizations on our own planet might tell us about civilizations that could exist elsewhere. We are going to consider the vast stretches of time that came before us, the billions of years during which stars were forming and planets were cooling, and possibly minds were waking up somewhere in the dark. We are going to think about what it might mean for a civilization to be truly ancient, not a few thousand years old the way ours is, but millions of years old, or hundreds of millions. We are going to imagine what those civilizations might have built, and what they might have become, and why, despite all of that, the sky remains so quiet. And somewhere along the way, you will probably fall asleep, and the questions will still be there when you come back to them. They are patient questions. They have been waiting for a long time already. Let us start at the beginning. Not the beginning of the universe, not yet, but the beginning of what we know about ourselves. Because before we can ask where everyone else is, it helps to understand where we are, and how we got here, and how remarkable, or perhaps how ordinary, our own story really is. Humanity as a civilization is young, embarrassingly young, cosmically speaking. The universe is approximately 13.8 billion years old. Our sun, our particular star, is about 4.6 billion years old. Life on Earth appeared somewhere around 3.5 to 4 billion years ago, which means life has been here for roughly the same amount of time as the sun has been burning. But complex life, multicellular life, animals, took much longer. The Cambrian explosion, the moment when life on Earth seemed to suddenly burst into a spectacular variety of forms, happened only about 540 million years ago, and modern humans, Homo sapiens, have only been around for about 300,000 years. 300,000 years. In the context of the universe, that is almost nothing. It is less than nothing. If you compressed the entire history of the universe into a single calendar year, with the Big Bang happening on January 1st at midnight, human beings would not appear until about 11:59 on December 31st. We would be the last few seconds of an entire year. Our entire recorded history, everything from the first writing in ancient Mesopotamia to this video you are listening to right now, would occupy the final fraction of the final second of that year. A blink. Less than a blink. And here's the thing about that. If we could appear in those final seconds, in that tiny sliver of cosmic time, then civilizations that appeared earlier in that year, civilizations that arose millions or hundreds of millions of years before us, would be so far ahead of us that the difference between their intelligence and ours might be like the difference between a thunderstorm and a thought. We cannot really imagine what a civilization that has had 1,000,000 years to develop would look like. We can barely imagine what our own civilization will look like in 1,000 years. Think about where we were 1,000 years ago. In the year 1025 or so, there were no cars, no electricity, no running water in most places, no antibiotics, no understanding of genetics or atoms or the speed of light. The most advanced technology on Earth at that time was a watermill or a well-crafted sword. Now think about how much has changed, and then try to imagine not 1,000 more years of that kind of change, but 1 million, or 10 million, or 100 million. The mind reaches for that image and finds nothing. There is no shelf to put it on. It is simply too large, and this is precisely why the Fermi Paradox is so strange. Because if civilizations like that exist, civilizations that have had millions of years to develop, they should have left marks on the universe that we could see. They should have done things, big things, things we could detect, things we could not miss, and the universe, as best as we can tell, is clean. It is empty. It is quiet. Unless, of course, it is not. Unless the marks are there and we simply do not know how to read them yet. Or unless the civilizations that came before us are so far beyond what we can comprehend that their presence looks, to our instruments and our limited understanding, exactly like nothing. Or unless something happened to them. Something that happens to every civilization, eventually, at a certain point in their development, something quiet and final and as inevitable as the arc of a stone thrown into still water, rising and then falling, touching the surface and then gone. We will get to that. But first, let us spend some time with the ancient civilizations of our own world, because they have something to tell us. Not about aliens, not directly, but about time, and about what gets lost in time, and about how much of any civilization, however remarkable, survives the long erosion of the years. Consider the civilization that built the pyramids at Giza. We know they existed. We can see their work. The Great Pyramid of Khufu is still standing after roughly 4,500 years, and it is still one of the most precisely engineered structures on Earth. The base of that pyramid is leveled to within 2 centimeters across an area covering 13 acres. Modern engineers, with all of their lasers and computers, find it genuinely difficult to replicate that kind of precision. And yet the people who did it used copper tools and wooden sleds and a level of organizational intelligence that we are still working to fully understand. Now, 4,500 years seems like a long time to us. It is a long time by any human measure, but in the context of the universe, it is nothing. It is less than nothing. It is 1/1,000,000th of the age of the Earth. The pyramids are ancient by our standards, and they are practically brand new by the standards of the cosmos. And here is something worth sitting with. Something worth letting settle into your thoughts as you breathe slowly and feel the weight of your body against wherever you are lying right now. If the pyramids are already so old that most of what the people who built them believed, knew, created, and experienced is lost to us completely. If 4,500 years is enough time to erase most of a culture, most of a language, most of a way of seeing the world, then what would be left of a civilization after 10 million years? What would be left after 1 billion? The answer, almost certainly, is nothing that we would recognize. Maybe nothing at all. And this is where the ancient civilizations of our past begin to speak to the ancient civilizations that might exist or might have existed somewhere out there in the dark. Because what we learned from our own history is that civilizations are fragile things. They rise, they flourish, they reach for something, they leave marks, and then, slowly or suddenly, they fade. What survives is almost always less than what was there. A pyramid here, a fragment of writing there, a story passed down so many times that it has become unrecognizable as history, and looks, instead, like myth. Imagine a civilization on some planet 300 million years ago. A civilization that had cities and science and art and music. A civilization that asked questions about the universe and maybe even found some answers. What would be left of them now, 300 million years later, on a planet that has had plate tectonics and erosion and volcanic activity and ice ages working on it this whole time? The answer is probably nothing. Not a single stone. Not a single signal. Not a trace. And if that is true, then the universe could be full of civilizations that rose and fell and vanished long before our own sun even formed, and we would have no way of knowing. The silence of the cosmos might not be emptiness. It might be the silence of a library that burned down so long ago that we do not even know it was there. That thought is both sobering and, in a strange way, deeply comforting, because it means we are not necessarily alone. We may simply be late. We may be arriving at a party that is already over, walking through rooms that were full of laughter and light just a few 100 million years ago, and finding only the shape of the furniture where people used to sit. Or perhaps the party is still going on, in rooms we have not found yet, behind doors we do not yet know how to open. The universe, after all, has not finished with us yet. We are still very early in our own story. Whatever we become, whatever we eventually reach for, is still ahead of us, somewhere in the deep and patient dark. And as you breathe, and as the sounds of wherever you are begin to soften around you, and as the edges of your thoughts start to blur the way they do when sleep begins to come, consider this. Every atom in your body was forged in a star. Every breath you take contains molecules that have been cycling through this world for billions of years. You are not separate from the universe that contains all these mysteries. You are made of it. You are a part of. The same story that may have been playing out on 1,000 worlds before ours, and may continue playing out on 1,000 worlds after. You are ancient in the most literal sense, and you are still here, still thinking, still wondering, in the last few seconds of December 31st, in the great calendar of the cosmos. We have only just begun to ask the questions. There is so much more to explore, and we will explore it together, slowly, in the hours ahead, moving deeper into the silence of the universe and what it might be trying to tell us, or what it might simply be waiting for us to be ready to hear. For now, let the images settle. Let the numbers drift. Let your body grow heavy and your breath grow slow. We are in no hurry. The stars have been waiting for billions of years. They can wait a little longer, and so can the answers. There is something almost meditative about returning to a question you cannot answer. Most questions, when you cannot answer them, create a kind of friction, a restlessness, an itch that demands to be scratched. But the Fermi Paradox is different. The Fermi Paradox, when you sit with it long enough, begins to feel less like an unanswered question and more like an open window. You do not need to close it. You do not need to find the answer tonight. You can simply sit near it and feel the air that comes through, cool and vast and carrying the faint scent of something you cannot quite name. We left off thinking about what time does to civilizations. We thought about the pyramids, about how 4,500 years is already enough to erase most of what a culture was, most of what it knew and felt and believed. We thought about a civilization that might have existed 300 million years ago, on some planet we will never find, and how nothing of it would remain. No stone, no signal, no whisper. Just the empty space where it once was, patient and indifferent, the way space always is. Now let us go a little deeper, into that idea. Let us follow it the way you might follow a thread through a dark room, not knowing exactly where it leads, but feeling it in your fingers and trusting that it goes somewhere. One of the things that makes the Fermi Paradox so quietly fascinating is that it forces us to confront something we are not very good at confronting, which is deep time. We are comfortable with human time. We understand decades. We have a feel for centuries, at least in the abstract. We can look at a cathedral that took 200 years to build and appreciate the span of that. We can read about the Roman Empire lasting 500 years and form some picture of it in our minds. But when the numbers get larger, when we start talking about millions of years or hundreds of millions of years, something in the brain simply steps back and says, I cannot picture this, and moves on. Deep time is not like human time stretched out longer. It is a different thing entirely. It is a scale on which everything we consider permanent, everything we consider lasting and solid and enduring, becomes fragile and temporary. Mountains rise and erode. Oceans appear and disappear. Continents drift like slow thoughts across the face of the planet. What feels fixed and forever to us is, in the language of deep time, just a brief arrangement, a temporary configuration, here for a moment and then reorganized into something else. Think of it this way. Imagine you have a sandcastle on a beach, a beautiful sandcastle, carefully built with towers and walls and little windows. That sandcastle represents a civilization. Now imagine the tide coming in, not quickly, not in a rush, but slowly, over millions of years, each wave just barely touching the base of the castle, each day wearing it down by almost nothing. Almost nothing, until one morning you come back to the beach and there is just flat sand where the castle used to be. No outline, no trace, no shadow of what was there. Just smooth, clean sand, as if the castle had never existed at all. That is what deep time does to civilizations. And if that is true for physical structures, for the things civilizations build, then how much more true is it for the signals they send? We have been broadcasting radio waves into space for about 100 years now. Our earliest radio transmissions, the ones we sent out without even thinking of them as messages to the cosmos, are now traveling outward in a sphere that is roughly 100 light years across. That sounds like a lot, and in human terms, it is. But 100 light years, in the context of the Milky Way, which is about 100,000 light years across, is a tiny bubble, a soap bubble floating in the middle of an ocean. Most of our galaxy has never heard us. Most of our galaxy does not know we are here. Now imagine a civilization that sent out signals 100 million years ago. Where are those signals now? They have traveled 100 million light years in every direction. They have long since passed beyond our galaxy, beyond our local group of galaxies, spreading through the universe like ripples from a stone dropped into a pond that has no edges. They are out there, those signals, diluted now to almost nothing, stretched thin across distances we cannot measure or imagine. Our instruments cannot detect them. We would not know what to listen for. We would not know what frequency, what pattern, what language. They are there, and we are deaf to them. This is one of the gentler proposed solutions to the Fermi Paradox, and it is worth resting on for a moment because it is both scientifically reasonable and strangely comforting. The universe may not be silent. We may simply not have the ears for what it is saying. We are like a person sitting in a room filled with conversation in languages they have never heard, and interpreting that as silence, because nothing they hear resolves into meaning. Have you ever been in a foreign country, somewhere where you did not speak the language at all, and found yourself surrounded by conversation, by laughter, by the sound of people connecting and communicating, and yet felt completely isolated inside it, because none of it landed as anything other than sound? The experience can feel strangely lonely, not because there is no connection around you, but because you have no way to receive it. The connection is there. The communication is real, but you are outside of it for now. That may be exactly where we are, cosmically speaking. Outside of a conversation that has been going on for longer than our planet has existed, unable to decode it because we do not yet have the tools, or the context, or the patience, or the right kind of quiet to really listen. Let us think for a moment about what ancient civilizations might actually look like. Not ancient the way Egypt is ancient, not ancient the way Rome is ancient, but truly ancient, cosmically ancient. Civilizations that have had not thousands but millions of years to develop. What does a million years of technological progress look like? We can try to estimate, at least roughly, by looking at our own trajectory. In the last 200 years, we went from horse-drawn carriages to spacecraft that have left the solar system. In the last 100 years, we went from having no idea what a gene was to being able to edit the genetic code of living organisms with precision tools. In the last 50 years, we built a global network of information that connects nearly every human being on Earth in near real time. The pace of our development, while it can feel slow from inside it, is actually extraordinary when you step back and look at it from a distance. Now extrapolate that. Not 200 more years, not 1,000 more years, 1,000,000 more years? 10 million? 100 million? What does a civilization look like after 100 million years of that kind of development? We genuinely do not know. We do not have the conceptual vocabulary to describe it. But scientists and philosophers have tried, and some of their ideas are worth sitting with tonight, because they are strange and beautiful, and they have the particular quality of things that might be true, even though we cannot prove them. One framework that is often used when thinking about ancient civilizations in space is something called the Kardashev scale. A Soviet astronomer named Nikolai Kardashev proposed it in 1964, and it is one of those ideas that, once you hear it, reorganizes the way you see things. The basic idea is simple. You can measure how advanced a civilization is by how much energy it can harness and use, not by how smart it is, not by how philosophically developed it is, not by how beautiful its art is, but by how much power it can access and direct. A Type 1 civilization, by this framework, can use all the energy available on its home planet. All of it. Every sunbeam that falls on its surface, every wind, every wave, every source of heat and radiation that its world provides. We are not quite there yet. Humanity is currently estimated to be at about 0.7 on the Kardashev scale. We use a significant amount of our planet's energy, but not all of it. Getting to Type 1, by some estimates, would take us about 100 to 200 more years at our current rate of development. A Type 2 civilization can use all the energy output of its star, all of it, every photon, every particle of radiation that pours out of its sun in every direction. To do this, some scientists have imagined a structure sometimes called a Dyson sphere, after the physicist Freeman Dyson, who described it, which is essentially a giant shell or swarm of structures that would surround a star completely, capturing all of its energy output. The energy available to a Type 2 civilization would be so enormous that it would be essentially incomprehensible by our current standards, and crucially, a Dyson sphere would be detectable. If any civilization in our galaxy had built one, we might be able to see it, because it would block the visible light of its star while radiating heat in the infrared spectrum. We have looked for signs of Dyson spheres. We have found some candidates, some stars that seem to dim in unusual ways, but nothing confirmed. A Type 3 civilization can use all the energy of its entire galaxy, all of it. Every star, every source of radiation, every erg of power that an entire galaxy of hundreds of billions of suns produces. A Type 3 civilization would, in some real sense, be a godlike entity by any standard we can apply. It would be so far beyond us that the comparison is almost meaningless. It would be like a single bacterium trying to comprehend a human city. And here is where the Fermi Paradox sharpens into something truly strange. If any civilization in our galaxy had reached Type 3, or even advanced Type 2, we would almost certainly know. The evidence would be unmistakable. Our galaxy would look different. It would behave differently. There would be signs everywhere. And yet our galaxy, as far as we can tell, shows no sign of any civilization beyond the one sitting here on this small pale blue dot, wondering about all the others. Think about what that means for a moment. Really sit with it. Either no civilization in our galaxy has ever reached that level of development, or they have reached it and are somehow invisible to us, or something happens before they get there, something that stops them, something that has stopped every civilization before they could become the kind of presence we would not be able to miss. This third possibility has a name. It is called the Great Filter. The Great Filter is perhaps the most haunting concept in all of this territory we are exploring tonight. It is the idea that somewhere along the path from simple chemistry to spacefaring civilization, there is a barrier, a filter, something so difficult, so unlikely, so catastrophically hard to get through that almost nothing makes it to the other side. A step in the development of a civilization, or a planet, or a species that almost always ends in failure. A wall that almost everyone hits and almost no one climbs. And the terrifying question, the one that makes this idea so uncomfortable that some scientists prefer not to think about it too directly, is whether that filter is behind us or ahead of us. If the filter is behind us, if the step that almost no civilization gets through is something that already happened in our past, then we are the rare exceptions. We are the ones who made it through against all odds, and the reason the universe seems empty is that almost no one else did. Maybe the filter is the development of the eukaryotic cell, the complex type of cell with a nucleus that eventually led to all complex life on Earth. That step took about 2 billion years to happen here, and may be extraordinarily rare. Maybe the filter is the development of sexual reproduction, or of multicellular life, or of the particular kind of brain chemistry that leads to language and abstract thought. If any of these steps is the filter, then we are on the other side of it. We made it. And the universe is quiet because most planets never got this far. That interpretation is actually somewhat reassuring. It suggests we are extraordinarily lucky, extraordinarily rare, but it does not imply doom. We got through the hard part. The road ahead may be difficult, but the worst obstacle is behind us. But if the filter is ahead of us, if the step that almost no civilization survives is something we have not yet reached, then the silence of the universe might be a warning. It might be the silence of a road where many travelers have set out and none have returned. And we are still walking. We are going to think about what that filter might be. We are going to think about it slowly and carefully, because it deserves care, and because there is actually something important and grounding and even peaceful in facing that possibility fully rather than looking away from it. But first, let us soften the edges of that thought. Let us put it down for a moment and pick up something a little gentler. There is another proposed solution to the Fermi Paradox that is worth spending time with tonight, one that is less about doom and more about perspective. It is sometimes called the zoo hypothesis, and it has a quality that might make you smile quietly in the dark. The zoo hypothesis suggests that advanced civilizations are not absent from our part of the universe. They are here. They are watching. They have simply chosen not to make contact, the way a researcher observing wildlife chooses not to disturb the animals. Not because the animals are not interesting, not because they do not matter, but because interfering would change what is being observed, would alter the natural development of something that is better, understood from a distance. On this view, we are the exhibit. We are the nature preserve. We are the species being given space to grow at our own pace, watched perhaps with something like curiosity or care, or that particular kind of patience that only very old things possess. The patience that comes from having so much time that a few thousand years of a civilization finding its way is a small and charming thing to observe. There is something in this idea that, once you let it settle, feels less isolating than it might first appear, because it suggests that the silence is not indifference, it is consideration. It is the silence of someone sitting very quietly in the corner of a room because they do not want to startle the sleeping child. It is a careful silence, a kind silence. Whether or not it is true, it is a beautiful way to hold the question. And it is worth noting that beauty is not nothing when it comes to ideas like this. The ideas we choose to sit with, the frames we choose to use when looking at the unknown, shape our experience of that unknown in real and important ways. And choosing to hold the silence of the universe as a kind of patient attention rather than cold absence is not naive. It is simply one of the reasonable interpretations of the evidence, which is, ultimately, no evidence at all. Consider for a moment the civilizations of our own deep past, the ones we know about through archaeology and history, the ones that left enough behind for us to piece together a rough picture. The Indus Valley Civilization, which flourished in what is now Pakistan and northwestern India, roughly 4,000 to 5,000 years ago, was one of the most sophisticated urban cultures of the ancient world. They had indoor plumbing, they had standardized weights and measures, they had cities laid out in careful grids, with sophisticated drainage systems that most cities in the world would not match for thousands of years afterward. And then they declined. And what we know of their language cannot yet be read. Their script has never been deciphered. Whatever they wrote, whatever they thought, whatever stories they told their children at night, is locked away in symbols we have found but cannot open. Or think about the civilization that built Göbekli Tepe in what is now southern Turkey, a site of enormous, elaborately carved stone pillars arranged in circles, constructed by people who, according to everything we previously thought we knew, should not yet have been capable of building anything like this. It is at least 12,000 years old, perhaps older, built before the invention of pottery, before the development of writing, before the beginning of what we typically call civilization. And yet here it is, undeniable and massive and full of carvings of animals and abstract symbols that we do not fully understand. Who built it? Why? What did it mean to them? What did they believe about the world and about the sky above them when they stood between those stones? We do not know. And what strikes me about Göbekli Tepe, what I want you to carry with you into the soft edges of sleep tonight, is this. If we cannot fully understand a civilization that existed 12,000 years ago, on our own planet, among our own ancestors, a civilization that left behind stone structures we can walk up to and touch, then what chance do we have of detecting or understanding a civilization that existed on another planet, in another star system, 1,000,000 years ago? The answer is almost none. And so perhaps the universe is not empty. Perhaps it is full to the edges with the traces of things we do not know how to see. Perhaps what looks like silence, when we point our radio telescopes at the sky and listen, is not silence at all, but a language so old and so different from anything we have ever heard that it registers in our instruments simply as noise, background noise. The hiss and crackle that comes with every signal, the thing we filter out before we look for the message, when maybe, just maybe, the noise is the message. Maybe the universe has been speaking to us this whole time, and we have been patiently, diligently, carefully ignoring it. There is a concept in music called negative space. It is the silence between the notes. A skilled composer knows that the silence is not the absence of music. The silence is part of the music. It is what gives the notes their shape, their weight, their meaning. Without the silence, the notes would blur into each other and become formless. The silence is not nothing. The silence is structural. The silence is load-bearing. Perhaps the cosmic silence is something like that. Not the absence of civilization, but the shape that civilization takes when it has existed long enough to stop making noise in ways that young civilizations recognize as noise. Not nothing, but something so different from what we expect to hear that we have learned to look right through it without seeing it. And with that thought, let it drift. Let the images drift. Let the numbers and the names, Kardashev and Fermi and Göbekli Tepe, let them float gently to the surface of your mind and then drift back down, the way leaves drift to the bottom of a still pond. You do not need to hold them. They will be there. The universe is patient. The questions are patient. And you are here, warm and breathing, in a moment of extraordinary stillness, on a planet that has been circling its star for 4.5 billion years, asking the same questions that the universe may have heard from 1,000 other worlds, in 1,000 other moments, just like this one. Rest now. There is more to explore, and we will get there slowly, in the soft and patient dark. There is a particular kind of peace that comes from accepting that some questions are larger than answers. Not the peace of giving up, not the peace of not caring, but the deeper peace of recognizing that living inside an open question is not a problem to be solved. It is a way of being. It is, in fact, one of the most human things there is. And tonight, in this quiet stretch of time before sleep fully comes, we have been living inside one of the largest open questions anyone has ever thought to ask. Where is everybody? We have been walking around that question from different angles, the way you might walk around a very large, very old tree in the middle of a field, circling it slowly, noticing how it looks different depending on where you stand. From one side, it looks like a puzzle. From another, it looks like a warning. From another, it looks like an invitation. And from yet another, if the light is right and you are in the right kind of mood, it looks almost like a comfort. Let us come back to the great filter one more time, because it deserves another look. We touched it earlier, and then we set it down gently. And now we can pick it back up with steadier hands and look at it more carefully, without flinching, because flinching is not necessary. These are ideas, not dangers. They are thoughts, and thoughts cannot hurt you, especially not here, not now, not while you are warm and comfortable and the darkness around you is your own familiar darkness, not the darkness of space. The great filter, to revisit it briefly, is the idea that somewhere between the chemistry of a young planet and the spacefaring civilization of a mature species, there is a step so difficult that almost nothing gets through it. A bottleneck so narrow that the vast majority of all possible civilizations, all the life that arises and begins to develop and reach toward complexity, hits this wall and goes no further. And the question that matters most for us right now, in this moment in our own history, is where that filter is. Consider the possibility that we have already passed it. Consider, for a moment, how unlikely our own existence actually is. The Earth sits in what astronomers call the habitable zone of our Sun, close enough to be warm, far enough not to be cooked, in a band of orbital distance sometimes called the Goldilocks zone, where liquid water can exist on a surface, where the conditions for life as we know it can arise and persist. But the habitable zone is not enough. We also got lucky with our moon, a large stabilizing presence that keeps our planet's axial tilt steady enough to prevent the kind of wild climate swings that might make complex life impossible. We got lucky with Jupiter, our giant outer planet, which acts like a gravitational shield, catching or deflecting many of the asteroids and comets that might otherwise strike us far more frequently than they do. We got lucky with the timing of our position in the galaxy, far enough from the violent, radiation-heavy galactic center to be relatively safe, but not so far out in the sparse outer arms that our star formed from material poor in the heavier elements that make rocky planets possible. We got lucky so many times, in so many ways, that some scientists have argued the Earth is not just unusual, but genuinely rare, perhaps even unique, at least in terms of how perfectly suited it is for the kind of complex, long-lived life that eventually produces minds capable of asking these questions. This view is sometimes called the rare Earth hypothesis, and it suggests that the filter, or at least one of the filters, is the sheer improbability of a planet like ours existing at all. But let us sit with the other possibility, too, because it is worth the discomfort of sitting with it. Let us consider the possibility that the filter is ahead of us. What might it be? Some thinkers have suggested that the development of nuclear weapons is itself a filter moment, a point at which a civilization has the technological capacity to destroy itself before it has the wisdom not to. We reached that moment in 1945, and we are still here, which is something, but we have also come closer to the edge than most people realize, not once but several times, through miscommunication and equipment failure and human error, in moments that were only resolved by luck and the quiet courage of individual people who chose, in the crucial second, not to press the button. Others have suggested that climate change, or more broadly the ecological disruption that comes with industrial civilization, is a filter, a moment when a species that has learned to harness enormous energy finds that the byproducts of that energy use destabilize the very conditions that made its civilization possible. A kind of tragic irony built into the structure of technological development, where the tools that allow a civilization to grow are the same tools that eventually threaten its survival. Others still have pointed to artificial intelligence, to the possibility that any sufficiently advanced civilization will eventually create minds more capable than their own, and that what happens after that is either transcendent or catastrophic or both, and that the silence of the universe might be, in some sense, the silence of civilizations that went through that transition and came out the other side as something that no longer communicates in ways recognizable to younger species. All of these are genuine proposals, seriously considered by serious people, and what they share, what makes them all worth holding in mind together rather than separately, is that they are all versions of the same underlying idea, that there is something in the nature of intelligence itself, something in the nature of what it means to be a thinking, tool-using, energy-harnessing species that carries within it the seeds of its own undoing, that the very qualities that allow a civilization to rise are the qualities that make it fragile in a particular way, a fragility that becomes visible only after a certain threshold is crossed. And yet, here we are, still thinking, still asking, still lying in the dark and wondering. That matters. That is not a small thing. Let us shift the lens now and look at this from a different direction, because we have been spending time with the darker interpretations of the silence, and it is worth spending equal time with the ones that are gentler, that leave more room for wonder, that do not require catastrophe as their central premise. One of the most fascinating and underappreciated proposed solutions to the Fermi Paradox is sometimes called the transcension hypothesis. It was proposed by a futurist and researcher named John Smart, and it goes something like this. Perhaps the trajectory of all advanced civilizations is not outward into space, getting bigger and louder and more visible, but inward into complexity, getting smaller and quieter and more intricate. Perhaps the natural direction of development for any sufficiently advanced intelligence is not to spread across the galaxy building Dyson spheres and sending radio signals in every direction, but to miniaturize, to dive deeper into the substrate of reality, to explore the inner universe of complexity and information rather than the outer universe of rocks and space. Think about your own experience with technology over your lifetime, or over the lifetime of the people you know. Computers used to fill entire rooms. Then they fit on a desk, then in your pocket, then on your wrist. The trend is not toward bigger and louder, but toward smaller and more powerful, more sophisticated, more capable of doing extraordinary things in an extraordinarily small space. If that trend continues, if it continues for not decades but millions of years, then a civilization at the far end of that trajectory might have compressed its entire existence into something so small and so intricate that it is invisible to us. Not because it is hiding, not because it is gone, but because it has gone somewhere we cannot follow yet. Inward, into the deep structure of matter and information, into a kind of existence that leaves no large-scale footprint in the physical universe at all. On this view, the silence of the cosmos is the silence of things that have gotten very, very good at being small. And there is something in that image, something in the idea of civilization turning inward rather than outward, that resonates with something much closer to home, because it is not entirely unlike what happens in a human life or in a human mind as it matures. The young person reaches outward, expands, takes up space, makes noise, leaves, marks everywhere. The older person, the wiser person, often moves in the opposite direction, deeper rather than wider, quieter rather than louder, more interior, more attentive to what is already present rather than always seeking what is next and new and over the horizon. Maybe civilizations are like that too. Maybe the universe is full of very old, very wise, very quiet things that have stopped making the kind of noise we would recognize as noise, because they no longer need to. Consider, for a moment, the night sky above you right now, or the sky you would see if you could step outside and look up. Every star you can see is a sun. Many of them have planets. Some of those planets are old enough to have had billions of years of chemistry happening on their surfaces. And somewhere in that sky, on some of those worlds, in some of those systems, something happened. Something grew complex. Something developed over time into something that could look back at its own sky and wonder about the lights it saw there. Some of those somethings are probably gone now, ended by asteroid or ecological collapse or the simple mathematics of stellar evolution, their suns having grown too bright or too cool or too unstable to sustain the conditions their life needed. Some may have run into their great filter and not made it through. Some may have passed through and continued developing into things we cannot imagine. Some may be, right now, in this moment, exactly where we are, young and curious, and reaching outward, building their first primitive instruments to listen to the cosmos, hearing nothing and wondering, just as we do, if they are the only ones. That thought, the thought of other young species sitting in their equivalent of this darkness, asking their equivalent of this question, is one of the most quietly companionable thoughts available to a human being at this particular moment in history, because it means that even in the silence, even in the apparent emptiness, we might not be as alone as we seem. We might be alone in the same way that two people in different rooms of the same house are alone, each in their own space, each in their own quiet, and yet sharing the same structure, the same walls, the same night outside the windows. The Milky Way is our house, and we are in one of its rooms with the lights low, listening. Have you ever noticed how the really deep questions, the ones that do not have easy answers, tend to circle back on themselves? You think about them for a while, and they lead you outward, further and further from yourself, and then somehow they lead you back to something personal, something immediate, something that has nothing to do with galaxies or light years or ancient civilizations, and everything to do with what it feels like to be here, now, alive, in this particular body, on this particular night. The Fermi Paradox does that. You start with a question about where all the alien civilizations are, and you end up, if you follow it far enough, asking questions about your own civilization, about what we are building, and what we might be destroying, and what we value, and what we are reaching for, and whether we are the kind of species that makes it through, or the kind that gets close and then does something irreversible. And then, if you are very lucky, or very tired, or both, you let that question go too. And what is left is just the fact of being here, just the breath, just the dark, just the ancient starlight. Passing through the window or through the ceiling, or through however many miles of atmosphere and cloud between you and the sky, those photons that have been traveling for years, or decades, or centuries, finally arriving at this particular place at this particular moment, where you happen to be lying with your eyes closed, letting the universe ask its questions without demanding that you answer them tonight. You are made of the same stuff as all of it. The carbon in your body was forged in the heart of a star that died before our sun was born. The iron in your blood is the signature of stellar explosions so violent they briefly outshone entire galaxies. The water in your cells has been cycling through oceans and clouds and rivers and living things for billions of years, long before the first fish swam, long before the first tree stood, long before the first human looked up and noticed that the lights in the sky were not just lights. You are not separate from the mystery. You are part of it. You are one of the universe's ways of wondering about itself, and that is not a small thing to be. That is perhaps the most extraordinary thing in all the territory we have covered tonight. Think about what it means that the universe produced creatures that can ask where everyone else is. That produced minds capable of looking at a sky full of stars and feeling the weight of the silence and trying to understand it. The universe did not have to do that. There is nothing in the laws of physics that required it. And yet here we are doing exactly that, in the small hours of a night that is just one of billions of nights on this planet, which is just one of billions of planets in this galaxy, which is just one of trillions of galaxies in the observable universe, which is itself perhaps just one small region of something so much larger that we do not yet have the mathematics to describe it. And in all of that, in all that incomprehensible vastness and age and complexity, there is this, your breath, your thoughts, drifting now, slower than before, softer than before, like snow settling rather than falling. The particular quality of the dark in this room, the particular silence of this moment, the ancient civilizations, whoever they were, wherever they were, whatever they built and knew and dreamed, they had their moment too. They lay in their own darkness and looked at their own stars and felt, perhaps, something not entirely unlike what you feel right now. That mix of smallness and wonder, and something that is not quite loneliness but is adjacent to it, that comes from being a thinking thing in a universe that is mostly not thinking, mostly just being, vast and old, and absolutely, perfectly indifferent. And yet, the indifference is not cold. Not really. That is what you learn, if you sit with it long enough. The universe is not hostile. It is not cruel. It is not anything, in the way that we are something. It is simply there, ancient beyond reckoning, patient, beyond any measure, containing within itself every question and possibly every answer, waiting with no urgency whatsoever for the right minds to come along and find them. We are those minds. Or we are trying to be. We are young, as these things go, embarrassingly young, just barely awake, just beginning to open our eyes on the vastness that surrounds us. But we are trying, and trying is not nothing. Trying, in fact, might be everything. The stars above you right now are the same stars that shone over every civilization that has ever existed on this planet. They shone over the people who built Göbekli Tepe, over the engineers who leveled the base of the Great Pyramid to within 2 centimeters across 13 acres, over the astronomers of the ancient world who mapped the movements of the sky with nothing but their eyes and their patience and their willingness to look up night after night without ever expecting an answer, simply because the looking felt necessary. Simply because the sky was there, and it was beautiful, and it meant something, even if they could not say exactly what. And those stars, right now, are also shining over whatever might be out there, over whatever worlds are turning in their orbits in the dark, over whatever chemistry might be happening, slowly, patiently, on some rocky surface somewhere in the warmth of some distant sun, over whatever minds might be forming, or already formed, or long since gone, having asked their own version of this question and found their own version of whatever peace or understanding waits on the other side of it. The silence is not empty. The silence is full, full of everything that has been and everything that might be, and all of it held in this immense and gentle and absolutely unhurried dark that is the true nature of space when you stop being afraid of it and simply let it be what it is. Let your body be heavy now. Let it settle. Let the thoughts that are still moving slow to a drift, and then to a float, and then to something barely distinguishable from stillness. The questions will be there in the morning. The stars will still be there. The paradox will still be waiting, patient as it always is, in no hurry whatsoever to be solved. You have spent this night in good company, the company of the oldest questions there are, and there is a kind of rest that comes only from that, from having followed something real and large and true for a while, from having let your mind range out across billions of years and trillions of stars and the quiet, beautiful, unresolved mystery of who else might be out there, and then let it come back, slowly, all the way back, to here, to this room, to this breath, to the simple, extraordinary fact of being alive on a living world, in a universe that produced you without knowing it was doing so, without intending anything, and yet somehow, here you are, wondering. And that is enough. That is more than enough. That is, in its own quiet way, the most remarkable thing in all the universe that we know about. The lights are out. The questions are resting. The stars are still burning, far away, in the dark, as they have always done, and will continue to do long after every question has been asked and forgotten and asked again by someone new. Sleep now. Somewhere out there, something ancient and unknowable is watching the same stars you are, from the other side of the silence. And maybe that is the closest thing to an answer we will ever find. Good night.